Hello everyone, welcome back to week 6 of the ECE9013 course. In last week's lectures, we discussed two new data types, mainly tuples, and we have discussed some of their properties, such as the fact that they are immutable, and lists, which are mutable data types, and we discussed the side effects of this property along with the concepts of aliasing and cloning. In this week's lecture, we will be focusing on two concepts. The first is the concept of recursion and how does it relate to a kind of divide and conquer algorithm. And the second concept is the concept of dictionaries, which is another mutable object type with similar side effects to lists. Starting off with recursion, as a definition, recursion is the process of repeating items in a self-similar way. To illustrate that, we will show it through an example. So the idea behind recursion is that we are trying to reduce the problem to a simple version of the same problem. To do so, we try to divide and conquer or decrease and conquer, which means we must have one or more base cases which act as the stopping condition that are easy to solve. The programming technique in this case is a function that actually calls itself. So it solves the same problem on some other input with the goal of simplifying the larger problem. So we know that repeated algorithms, or to repeat somehow an algorithm, we can use looping structures such as while loops and for loops. And we need to do a computation with a set of state variables such as counter or sum or average that are updated on each iteration. As an example, we can think of the multiplication as the equivalent of adding the same item multiple times. So for example, A multiplied by B is equivalent to adding A to itself B times. To do that, we can actually do it using iteration. So for example, if we define a function called mult_iter, which means we're trying to define a function that multiplies two numbers in an iterative manner, we start or initiate a variable called result as 0, and then we state while b is greater than 0, we add the value of a to result, and we decrease the value of b by 1 in order to have b iterations, and then we finally return the value of result after the loop is completed. This process can also be done in a recursive manner. So for example, as we mentioned, a multiplied by b is a added to itself b times. It's also a plus a repeated b minus 1 times. So this component can be written as a multiplied by b minus 1 plus a. So the recursive step reduces the problem to a simpler version of the same problem, and we keep reducing the problem until we reach a simple case, which is the stopping case. So the stopping case or the base case is solved directly. In this case, it's when b equal to 1. So in our case, to solve the multiplication problem in a recursive manner, we define it as if b equal to 1, we return a, else we return the output of a plus the multiplication of a, b minus 1. So now in this case, we would actually call this function again. Another example is the factorial being implemented in a recursive manner. So by definition, the factorial of a number n is the product of all of the integers from n to 1. So the base case or the stopping condition is factorial of 1 equal to 1 and a factorial of 0 is also equal to 1. And the recursive step is the product of n by the factorial of n minus 1. So implementing this, we define the function as fact of x and mention that if x is less than or equal to 1, we return 1, because as we mentioned earlier, the factorial of 1 is 1 and the factorial of 0 is 1. Else, the return is the product of x by the factorial x minus 1. So here we can see the flow of the scope of the value and what is the new value being saved. So in each recursive call to the function, we create a new own scope. It uses the same variable names in separate scopes. And bindings of variables in a scope are not changed by the recursive call. So the flow of control passes back to the previous scope once the function calls the return value.